series on computer organization and architecture. We'll discuss lecture number 38 of module number 4. Contents covered in the previous lecture are virtual memories. So virtual memory concept was discussed when we want to increase the size of the memory. So in case of virtual memory, so there is one important component called as an memory management unit was used. So the memory management unit is used to convert the address that is being generated by the processor, which we call it as a logical address or a virtual address, into a physical address. So physical address is nothing but it is the actual address where the data is available. So this virtual memory concept was introduced when we want to go with a when the size of the memory needs to be increased. So during that time virtual memory concept will be useful. Contents covered in this lecture are magnetic hard disk. So this magnetic hard disk comes under secondary storage devices. So under this lecture we are going to study magnetic hard disk system. So its important components, so how the data can be stored as well as how the data can be retrieved. Learning outcomes. After this lecture, the students will have a better understanding of magnetic hard disk system. So this is the Bloom's taxonomy pyramid. So here we are going to understand a basic concepts of magnetic hard disk system. So that is how the data can be stored as well as how it can be retrieved. What are the important components of the hard disk system? So all these things we are going to understand, hence it is going to fall under the Bloom's taxonomy level number 2. So before going to, we know that magnetic hard disk system, it comes under the category of secondary storage, or it is an example of secondary storage system. So before going to understand the example of secondary storage system, so in the previous lectures we have discussed semiconductor memories. So in case of semiconductor memories, the size of the memory is small as well as it is an volatile memory. So and the main limitation of that semiconductor memory is cost per bit of the stored information. So here semiconductor memories cannot be used to provide all the storage capabilities that is needed for the computers. So hence in order to, when we want to go for the larger storage capacity, and if we want a non-volatile memory, and even if we want to go with a reduced cost, so we are the three in order to achieve these three objectives, that is cost of the memory should be less, as well as we want to store the large amount of information, and even we are going to store the information in a non-volatile memory. So in order to go with these things, we are going to make use of a secondary storage device. A large storage system, which is large storage when we have a large storage requirements, so most of the computers are going with an economical realized, which is in the form of magnetic disk, optical disk, as well as magnetic tapes. So all these falls under the category of secondary storage devices, or these are the examples of the secondary storage devices. So under this we will be discussing regarding magnetic hard disk system. So here the magnetic hard disk system, it is used as a data storage device. So that is, it is used for storing as well as retrieval of digital information. So here the word we come across with the magnetic, so that is it will be consisting of, that is magnetic disk system, which is a secondary storage device. This system will be consisting of one or more number of disks. So those number of disks are mounted on a common spindle. So here as the word says magnetic, so here on each of the disk a magnetic film or a magnetic coat is deposited on each of the disk, that is normally on both the sides of the disk. So we will be considering, that is in a magnetic disk system there are number of disks. So on each and every disk we are going to make use of both the surfaces or both the sides of the disk. On both the sides of the disk a thin magnetic coat is available. So these disks are placed on the common spindle, so that is, which is a movable one, which is going to rotate the magnetic disk. So this, as I told, the discs are placed in a rotary drive so that the magnetized surface move in the close proximity to read or write heads. So we will be having a read and write heads, so that magnetized, that is the disc will be moving with the help of this rotary drive or the spindle. So when it comes near to the read and write head, automatically it can be used to store the information or retrieve the information. So this is how magnetic hard disk system looks like. So we have this magnetic disk which is a that is, it is a magnetic disk. There are several number of disks, so you can just see that there are number of disks. So these disks we normally even call it as a platters. So these disks are placed on the spindle. So the middle one which looks here is, this is the spindle. So all these disks are mounted on this common spindle. So this is the another name for the spindle is platters. So here we have a read write head. So this one is called as a read write head. So when the disk rotates, so it will be used for storing the information. That is when the disk is in the moving condition. So when it comes to the close proximity of read write heads, then information can be either stored or retrieved. So this is regarding magnetic hard disk, view of the magnetic hard disk system. So here the disk system, it consists of three main key parts. So as I told, we have a disk platters. So another name for the disk platter is, it is normally even we can call it as either as a platters or a disk platters. So here this is always referred as an, means usually it will be referred to be as an disk. So each disk platter has a flat circular shape. You can go through here. We have a flat circular shape. Each platter has two working surfaces. So on both the surfaces a thin magnetic film is deposited or a thin magnetic coat is given. So hence it is called as a magnetic disk. So that coating is given on both the sides. So and the shape of that magnetic disk is in the form of circular one, and you can store the information on both the surfaces. So normally that disk on the top, what we call it is called as an surface. So here we have one more important part called as disk drive, which is going to work on an electromechanical mechanism that is going to spin the disk and move the read write heads. So now, so we have a electromechanical disk drive. So this disk drive will be making the spindle to move this particular disk and even the read write heads also. And the third key component is called as an disk controller. So this disk controller, it is an electronic circuitry that controls the operation of the disk system. So it is used for the controlling of the operation of the disk system. So normally disk controller, it is going to keep track of defective disk and it is going to exclude them from the usage. So normally it is disk controller, it is going to contain the entire disk controller is going to contain the entire disk system, and it will be keeping a record, or it is going to keep track of the defective disk and it is going to exclude them from use. So here the term disk is often used to refer the combined package of disk drive and disk. So both disk drive and disk together we call it as an normally disk. So you can just see here. So this is the spindle, middle one, the central one, the vertical pipe like structure. So this is the spindle, or even we can call it as a rotary drive. So on this rotary drive, so we can place the disk. So disk is nothing but it is one which is in the form of circular shape that is coated with a magnetic material. So on the both sides of the disk, so all these disks are mounted on this particular spindle. The spindle is one which is going to rotate. So it is even called as a rotary drive shaft, and this is called as read write heads. So as we are going to read and write the information on both the surfaces of the disk, so we have read write head for each of the surface. So for every surface we have read write head. So this is the read write head. So the top read write head, this is the arm. This is the arm of the read write head, and this exactly this one we call it as a read write head. So as we are going to store the information on both the sides or both the surfaces of the disk, so we have for every surface we have a read write head. So one surface is equal to one read write head. If we are storing the information on that particular surface, then automatically we have read write head for that particular surface, so that there is one head per surface. So as I told that read or write heads are used for storing as well as for reading the information. So this read write arm controls the movement of read write heads. So this will be in the moving condition, and this we call it as an arm. So these are the arm, and this small box what we are seeing, so this is called as a read write head, and it is consisting of other components called as magnetic yoke and magnetizing current, means a magnetizing coil. So we have a magnetic yoke and we have a magnetizing coil. So on the every read write head we have a magnetic yoke and we have a magnetizing coil, and in between this read write head and disk we have a small air gap. So there is a small air gap. It is not exactly touched to the surface. So it is not touched to the surface. So there is a small clear air gap. So there is a small air gap between the read write head and the disk, or on the surface of the disk. So read write head must be maintained at a very small distance from the moving disk in order to achieve high bit densities and in order to achieve a reliable read write operations. So in most modern disk system, the disk and the read write heads are placed in a sealed air filtered enclosure. So as I told, we have an air gap over here. So we have a sealed air filtered enclosure that is between the disk and the read write. So to read or write the data on a given disk, the arm holding read write head must be first moved. So if I want to store any information or retrieve information, the arm has to move this read write head. So you can just check here. So this is nothing but here we have an arm. So this we call it as an read write arm, and this is the read write head. So that will be moved on that will be moved on the surface of the disk when we want to store any information or retrieve the information. So this read write head is made up of magnetizing coil and magnetic yoke, and there is a small gap between the disk and the read write head. So now let us discuss regarding organization and accessing of data on the disk. So here each surfaces, what we are calling it as a disk surface, that is the surface of the disk which is coated by the magnetic material. So every surface of the disk is divided into concentric tracks, and each track is divided into sectors. So let us discuss with that. So now if you are going to consider this circle as one disk, so we know that disk is in the form of circular shape. So this disk will be divided into concentric tracks. So that is they are divided into concentric tracks, and each concentric tracks each tracks is divided into sectors. So you can see the partitions. Each track is again divided into sector. So you can see this much portion. So black line. So this we call it as a sector, and the circles, concentric circles, we call it as an track. So the disk is divided into concentric track. Each surface, that is each disk surface is divided into concentric tracks, and each track again it is divided into sectors. So you can just see here we have an arm. So this is an arm, and here we have a read write head, and arm is available for read write head is available for both the surface of the disk, as you can just see here. And the middle line we call it as a spindle, which can be moved, that is which makes this disk to rotate, and these disks will be moving because of this spindle. It is a rotary drive shaft, and these we call it as a platters or the disk. And every surface of the disk are divided into tracks, and further tracks are divided into sectors. So each track is divided into sector. So you can just see here, so this circle we call it as track, and there again we have division in the form of sectors. So you can just see like it is in the form of pizza shaped structure. So this is called as one sector. So if you assume this partition as sector number 0, this is sector number 1, this is sector number 2, and this is sector number 3. And we have track numbers also, track number 0, track number 1, and track number n. So you can just see here, so this much portion we call it as track. So and we have multiple sectors. So these are the sectors. So I hope you got this. Like we have a track, it is in the form of concentric tracks. So we have circle shaped tracks, and every track we have a sectors. So here set of corresponding tracks on all the surfaces of a stack of a disk forms a logical cylinder. So you can just see here, so this is if you consider all the tracks of all the surfaces of a disk, so it forms like a cylindrical shape. So this is called as cylinder. This we call it as a cylinder. The set of corresponding tracks on all the surfaces of the stack disk forms a logical cylinder. The data on all the tracks of a cylinder can be accessed without moving a read-write head. So these data can be accessed by specifying the surface number, track number, as well as sector number. So I hope you got this concept. So this is an arm assembly. We have an read-write arm, and we have a read-write head. So these are the platters. Platters are placed on the spindle. So spindle will be in the moving. Spindle can move. Spindle makes to move this disk, and we have we can read or write the information on both the surfaces of the disk. So every surface of the disk is coated with a magnetic material, and this disk will be divided into, so this disk will be divided into concentric tracks. So each surface of the disk is divided into concentric tracks, and every track is divided into sectors. So you can just see the partitions. So these partitions we call it as a sectors, and this is one full track. And if we are going to concentrate on the tracks of all the surfaces on all the disk, we call it as a cylinder. That is set of corresponding track on all the surfaces of disk form the cylinder. So here you can just see here, let us consider this as one of the disk. So on this surface we have tracks. So tracks you can just see here. So this is one track and another track. This is a second track, and again this is one full complete track. So this one full circle we call it as track, and this is a second track number, and similarly we can have n number of tracks. So this complete one full circle. So this is from here till here, from this position to this position, we call it as a track. Again from this position to this position, we call it as a track. So several such concentric tracks will be available. So this full one, it makes one full track, and these tracks are divided into sectors. So we have a number of sectors. We can there are a number of sectors, that is tracks are divided into sectors. So say for example, this is sector number 1, sector number 2, sector number 3, sector number 4, 5, 6 and so on. So this is of track number 1. We have a number of sectors, and between from one sector to another sector we have an intersector gap. Similarly, from one track to another track we have inter-track gap. So this is an middle line, we have inter-track gap. So it is gap from one track to another track, and from one sector to another sector we have an intersector gap. So these are called as sectors. So here, so this is, you can just check out here. So this much of space we call it as track. So this is track number 1, track number 0 of sector number 0, track number 1 of sector number 0, like that. So that is sector number 6 of track number 1, sector number 6 of track number 2. This similarly, this is sector number 5 of track number 1 and sector number 5 of track number 2, so on. So this is regarding tracks, sectors, inter-track gap, intersector gap, as well as logical cylinder. So here data bits are stored serially on each track. So each sector usually consists of 512 bytes of data. The data are preceded by sector header. So whenever we want to store the information or retrieve the information, so it can be identified by using the addressing mechanism. So here first thing is that we are going to provide the address, so which is followed by data, and data is followed by error correcting code. So here the data are preceded by the sector header, so wherein this header is going to contains the address information. So that address information is going to find out the desired sector on the selected track. So once we are going to select the track, on the selected track on which sector we are going to read or write the information. So once the address information is going to provided, so next thing part we have the data. So the data part is followed by the additional bits. So that additional bits we call it as an error correcting code. So this error correcting codes are used to detect and correct the errors. So sometimes it may be possible that we can read or write the wrong information. So hence error correcting bits, it is used to detect or correct the errors that might happen during writing or reading the 512 bytes. So always keep in remember that, so that in every sector, that is in every track of a sector, we can store 512 bytes of information. So for example S6, in S6 I can store S6 of track number 1 I can store 512 bytes. S6 of track number next track I can store 512 bytes. Sorry, each sector usually contains 512 bytes, not with respect to tracks, that is with respect to sectors. With respect to sectors I can store 512 bytes of data. So here in order to distinguish between two consecutive sectors, there is a small intersector gap, as I told, the pink color line. So pink color line indicates intersector gap. So here blue part indicates it is a track. So this much is a track, and from this orange to this orange part, from here to here, we call it this as a sector. So we can read or write the information serially. So digital information can be stored on the magnetic. Now let us go with the how we can perform a read operation or write operation. So you can perform read or write operation by inducing some magnetic field and electrical field. So first let us discuss regarding write operation. So whenever a write operation needs to be happen, that is always remember that when we are storing any information in the magnetic hard disk system, we call it as a record. So here the digital information can be stored on the magnetic surface by applying a current pulse of a suitable polarity to the magnetizing coil. So we have a magnetizing coil over here. To this magnetizing coil, if we supply a suitable current pulse, so that suitable current pulse when we are going to supply to this magnetizing coil, so in the read write head, so this magnetizing coil is available in the read write head. So when I want to store any digital information on the magnetic surface of the disk, so I should apply a current pulse to the magnetizing coil which is available in the read write head. So this current in the magnetizing coil, it is going to cause the magnetization in the surface and it is going to generate the magnetic field. So whenever we are going to pass the current to the magnetizing coil, so it is going to generate a magnetic field. So that magnetic field in the area immediately below the read write head. So that is going to when it generates a magnetic field in the area immediately below the head to switch to a direction parallel to the applied field. So that is read write head transforms electrical current into a magnetic field. So that corresponding magnetic pattern is recorded on the surface. So what we are supposed to do when we are going to perform a write operation, pass a suitable current pulse to the magnetizing coil. So this magnetizing coil will be generating a magnetic field below the read write head. So when it is going to generate the magnetic field below the read write head, so that is electrical current will be converted to magnetic field. So that magnetic field corresponding to the magnetic pattern, the information will be recorded on the disk. So information is going to get recorded on the disk. So now this causes the magnetization of the film in the area immediately below the head to the switch to direction parallel to the applied field. So similarly, when we want to go for read operation, the same head can be used even for reading the stored information. So in this case, change in the magnetic field below that is in the vicinity of the head caused by the movement of the film relative to the yoke induces a voltage in the coil. So now we know that on the surface of the disk the information is stored. So suppose if I want to read that information, so we know that spindle will be rotating the disks. So whenever there is a change in the magnetic field below the head, so change in the magnetic field in the vicinity of the head due to the movement of the film or due to the movement of the surface or due to the movement of the disk which is relative to the yoke, that is going to induce a voltage in the coil. So that voltage in the coil now it acts, that is yoke acts as a that particular magnetizing coil, now it will be serving as a sense coil. So that is due to change in the magnetic field we are going to get a different data bits. So that is the polarity of this voltage is monitored by the control circuitry to determine the state of magnetization of the film. So only change in the magnetic field, so whatever the changes, the only changes in the magnetic field under the head can be sensed during the read operation. So therefore, if the binary states 0 and 1 are represented by the two opposite states of the magnetization, a voltage is induced in the head only at 0 to 1 and 1 to 0 transition in the bit streams. See, I repeat. So we will be because of movement of the disk or the surface or the film below the head of the read write head, so there will be an change in the magnetic field. That change in the magnetic field is going to induce the voltage in the magnetizing coil. So that magnetizing coil we are going to call it as a sense coil. So here, depending upon the value stored 0 or 1, so there will be change in the magnetic field. So here that is for 0 we have for 0 and 1 we have opposite states of magnetization. So that change in the magnetization is going to induce the voltage. So that will be identified only at the 0 to 1 and 1 to 0 transition in the bit stream. So this is how the read operation is going to occur. So conclusion is, we have discussed regarding magnetic disk system. So under magnetic disk system we are going to we have discussed how the magnetic disk are arranged. So we have discussed regarding the spindle, arm, read write head. So how to store the information and how to retrieve the information, and how that every disk surfaces are organized, that is tracks, sector, cylinder. So and even we have a address for every sectors. So all these things are discussed in this magnetic disk system. Thank you.